Hello friends, I welcome you in lecture number 17 on relations. In this lecture also we will discuss some more operations on relations. We have talked about union and intersection operations on relations in previous two lectures. Here we are going to discuss some more operations on relations. We can talk about difference of two relations also, and definition is same as we have discussed in set theory. R minus S is the notation for difference of sets R and S, or relative complement of S with respect to R, and this is defined as all those ordered pairs XY such that this ordered pair XY is a member of R and it is not a member of S. We will consider all those ordered pairs which are present in R and absent in S. So this is nothing but intersection of R and complement of set S. We are considering those ordered pairs XY which are present in R and which are not present in S, that means which are present in complement of S. Similarly, we are familiar with the symmetric difference of two relations. The notation for symmetric difference is sometimes they use this notation, and this is also another notation for the symmetric difference. So we know that symmetric difference is given by difference of union of two relations and intersection of two relations. So we are going to discuss all these operations for relations. Here I have taken this example. Let R1 be the less than relation on the set of real numbers and R2 be the greater than relation on the set of real numbers. That is, R1 and R2 both are defined on the set of real numbers. That is, R1 and R2 both are subsets of R cross R. R2 is also subset of R cross R. And the question is, what are R1 union R2, R1 intersection R2, R1 minus R2, R2 minus R1, and R1 plus R2, or symmetric difference of R1 and R2. So first we write down whatever is given. It is given that R1 is the less than relation on the set of real numbers. That means R1 is the set of all those ordered pairs XY which are in R cross R such that less than relation, that is X is less than Y. And similarly R2 denotes greater than relation. So R2 is the set of all those ordered pairs from R cross R such that X is greater than Y. This is the meaning of R1 and R2. R1 be the less than relation on the set of real numbers, that is R1 is subset of R cross R. So we consider all those order pairs from R cross R for which first component is less than second component. Similarly, R2 is subset of R cross R and it is greater than relation. Therefore, we collect all those order pairs from R cross R for which X is greater than Y. And we have to decide all these relations. First, we have to find out union of R1 and R2. Union of R1 and R2 means we have to collect those ordered pairs XY such that XY belongs to R1 or XY belongs to R2. XY belongs to R1 or ordered pair XY belongs to R2. This is the definition of union operation. R1 union R2 means collect all those elements which are present in either R1 or in R2 or in both the sets or both the relations. Now for order pair xy belongs to R cross R such that if xy belongs to R1, then it satisfies this condition, x is less than y, and if xy belongs to R2, it satisfies this condition, x is greater than y. This means either x is less than y or x is greater than y. Order pair xy belongs to R1 union R2. So x is less than y or x is greater than y, that we can combine as x is not equal to y. We can write these two conditions, that either x less than y or x greater than y. This is equivalent to the fact that x is not equal to y, because we know that if two real numbers are different, then either one is smaller than the other or one is greater than the other. So suppose I have two different real numbers on the real line, then we can say that either x is less than y or x is greater than y. So I can replace this condition by x is not equal to y, and this is the union of given relations R1 and R2. Next one is R1 intersection R2. So now we try to find out what is R1 intersection R2. So R1 intersection R2. So I have to consider all those ordered pairs from R cross R such that ordered pair xy belongs to R1 and ordered pair xy belongs to R2. Because of intersection, I am writing and here. I have to consider all those ordered pairs which are present in R1 and in R2. So order pair xy belongs to R1 if x is less than y. Order pair xy belongs to R2 if x is greater than y. So we must have both the conditions satisfied, because we are collecting all those order pairs xy such that xy belongs to R1, that is x is less than y, and xy belongs to R2, that is x is greater than y. So whether this is possible or not, if I take any two real numbers x and y, then whether this is possible or not, x is less than y as well as x is greater than y. So this is obvious that there is no order pair which satisfy both the conditions. If I take any two elements x and y in the set of real numbers, then there are different possibilities. Either x is equal to y, or x is less than y, or x is greater than y. But any of these three possibilities is correct at the same time. All the possibilities cannot be correct at the same time. That is, there is no order pair xy which satisfy both the conditions, x is less than y as well as x is greater than y. Therefore, their intersection is empty set. R1 intersection R2 is empty set. Next operation is R1 minus R2, that is difference of R1 and R2. So now we try to find out what is R1 minus R2. By the definition of difference of two sets, we have to write down all those order pairs from R cross R such that order pair xy belongs to R1 and order pair xy is not in R2, that is xy is not in R2. This means we have to write down all those ordered pairs from R cross R such that xy belongs to R1, that is x is less than y, and xy is not in R2. xy is in R2 if x is greater than y. If this condition is satisfied, xy is in R2. So if xy is not in R2, then this condition is not satisfied, that is either x is less than y or equal to y. So here we write that x is less than or equal to y. xy belongs to R2 if x is greater than y, but xy is not in R2, therefore either x is equal to y or x is less than y, and therefore we have this we have to combine these two conditions. We will collect all those elements or all those order pairs which satisfy both of these conditions, that is x is less than y and x is less than or equal to y. So intersection is x is less than y. If we consider both the conditions x less than y and x is less than or equal to y, then if I write this x less than y here, then both the conditions are satisfied. So this is R1 minus R2, and if we notice that R1 is nothing but x is less than y, so this is equal to R1. Now next relation is R2 minus R1, so that also we can decide exactly in this way. Now we can write for R2 minus R1. R2 minus R1, that means consider all those ordered pairs from R cross R such that now R2 minus R1, so xy belongs to R2 and xy does not belong to R1. We consider all those ordered pairs of R2 which are not present in R1. So this I can rewrite as xy belongs to R cross R. xy belongs to R2 if x is greater than y, because in R2 we have greater than relation, and xy is not in R1. R1 means consider all those order pairs for which x is less than y, but xy is not in R1, that means x is not less than y, that means either x is greater than y or x is greater than or equal to y. So now I have to write down all those ordered pairs xy from R cross R for which these two conditions are satisfied. So we can see that x greater than y and x is greater than or equal to y both are satisfied if x is greater than y, and this is nothing but relation R2 which is greater than relation. And last relation we have to decide is symmetric difference of R1 and R2. So that is also simple now, because we have obtained all these things which are required for this symmetric difference. So symmetric difference is given by difference of union of two relations and intersection of two relations, that is R1 union R2 minus R1 intersection R2, and we have obtained R1 union R2. R1 union R2 means consider all those ordered pairs for which x is not equal to y. So let me write that first. Order pair xy from R cross R such that x is not equal to y, and what is R1 intersection R2? It is empty set. R1 intersection R2 is empty set, so here we write minus empty set. That means this is equal to order pair xy in R cross R such that x is not equal to y. This is the symmetric difference of two relations R1 and R2. Consider all those ordered pairs from R cross R for which both the components are not equal. R1 plus R2 is also obtained now. So in this way we can decide all these operations and we can combine the given relations using all these operations. So this is all about this session. I hope you like it. Thanks for watching.